this works with this example. So the matrix originally was 2, 4, 2, 6, 2, 1, 1, 16, 1, 1, 2, 9. Now it's going to take at most 5 steps to get this into upper triangular. And remember, I want to have, if I can get this, this, and this to be zeros, we have what's called an upper triangular matrix, which would be really easy to solve. This is going to take at most 5 steps. The first step is to make that into a 1 somehow. And I'm going to do it by doing 1/2 row 1 into row 1. It actually could have been done almost easier by swapping, but I'm going to do it this way just to keep things simple. So you can always do that as your first step, just multiply by whatever fraction it takes to turn that into a 1. That will always work. So I've done 1 out of the 5 steps. Now I want to turn this 2 into a 0, and that could be done pretty easily. You just take -2 times row 1, add it to row 2, and put the answer into row 2. Now, something that gets confusing, I just want you to be aware of, is that even though I'm multiplying the first row by -2 to perform this operation, row 1 itself doesn't change in the matrix. It's just row 2 that changes. So I imagine 1 times -2 is -2 plus 2 is 0, like I want. 2 times -2 is -4 plus 1 is -3. 1 times -2 is -2 plus 1 is -1. 3 times -2 is -6 plus 16 is 10. And I've done 2 out of the 5 steps. Now I want to turn that thing into a 0. That's done by doing negative row 1 plus row 3 into row 3. So you zero stuff out by utilizing the 1 here. Now, just like before, row 3 is the only row that actually changes. Okay, now how does row 3 change? -1 times 1 is -1 plus 1 is 0. -1 times 2 is -2 plus 1 is -1. -1 times 1 is -1 plus 2 is 1. -1 times 3 is -3 plus 9 is 6. So now I've got 3 out of the 5 things done. Now you can get a bit creative here. My next step is to turn this thing into a 1. The most straightforward way is to multiply that entire row by -1/3, but that is going to make fractions here, and a lot of people don't want to deal with fractions if they can avoid them. So another option is just to swap row 3 and row 2. So row 2 and row 3 are going to swap. So that means row 1 has not changed. You could really only swap with something below it, so that we have to have a 0 here in order for that swap to work. And now I really wanted this thing to be a positive 1, so I'm going to do negative row 2 goes into row 2. Actually, could have skipped that step. It doesn't have to be a 1. A -1 is actually just as good as a regular 1, but I'll just stick to the formula here. Okay, we have 1, 2, 3, 4 out of 5 things done. Finally, the way we get rid of that 3 is by utilizing row 2, do 3 row 2 plus row 3 into row 3. Remember, row 1 does not change. Row 2 doesn't change, at least in the matrix it doesn't. But row 3 changes by doing 3 times 0 is 0 plus 0 is 0. 3 times 1 is 3 plus -3 is 0, like I want. 3 times -1, -3 plus -1 is -4. 3 times -6 is -18 plus 10 is negative 8. And, well, we've done the 5 steps, and now we can convert this back into the system of equations, which was the last equation was negative 4z equals negative 8. The second equation was y minus z equals negative 6, and the first equation was x plus 2y plus z equals 3. You work them backwards. If minus 4z equals negative 8, then z equals positive 2. Plug that z into here and get y equals negative 4. And plug both of those into the original equation. X plus 2y is going to be negative 8, plus z is plus 2 equals 3. Negative 8 plus 2 is negative 6. Add 6 to both sides, get 9. And the answer to this question is 9 minus 4, 2. And if there's time, have the class now practice on a big practice question, which is 4x minus 3y plus 2z equals 40, 5x plus 9y minus 7z equals 47, 9x plus 8y minus 3z equals 97. And they can work that out just so you know you're on the right track if you get z equals 3. Somehow I don't have the other two answers on me right now, but if you get z equals 3, you can work out the others. I'll get you those other answers also if I get a chance. Okay, well, if you're the person who's presenting lesson number 2, have fun with that, and I don't mean that sarcastically. I mean, I do want you to have fun with it. So, and I'll have a new lesson for the next day. Thanks.